Hi there. I'm so sorry about that last video. My screen was starting to go dark because it timed out and I hit the space bar and I happened to be on top of the record button. And so it ended the video, but I didn't know that and I kept on going and filled out the rest of the page. So I know we were right here just getting to the final answer as the video ended. So here the signs are different. That means subtract. 7 minus 4 is 3. Keep the sign of the larger, so negative 3x. And then last, combine like terms, the two constants, positive 6 and positive 1, positive 7. Okay, so sorry about that. I have my mouse not on top of the record button now. I made 400 videos during COVID and I got really good at them, but I haven't hardly made any since then. So bear with me. I'll get better each day, just like you guys will get better at math each day. Okay, this next section, I had you stop the video and fill it in. It is a translate section. There's 6 problems below. So translate each, and then I also wrote simplify just so you could practice combining like terms. I know on Alex on the translate section, they do not have you simplify, so they just have you translate and stop. But I wanted you to practice the simplifying from above. So this one does ask us to use a certain variable, and remember Alex does too. It has all kinds of random W, Z, C, so always read the directions so you know which variable to use when you're writing your translation. So there are 6 problems listed below. So go ahead and shut off your video, work the 6 problems, and I've already written them out because like I said, I was teaching to myself for the last 10 minutes. Well, until I realized it wasn't recording any longer. So go ahead and do those 6 and then turn the video back on and we'll check them together. Okay, for the first one, we have that from language again. That means 10 must be listed first because it's subtracted from 10. So we do 10 minus and then 3 times the number using the x asked for. So 10 minus 3x. So anything going from, the from quantities first, and then you subtract. For B, the sum of a number and 2, so you shouldn't even look at this last part. So we got x plus 2, because sum means add, and the number in front is x, the number after the plus sign is 2. And then it's a comma, which means all of this is divided by 5. Now, if there wasn't a comma, then you would have written x plus 2/5. But because of the comma, that means all of this is divided by 5, and it would look like this. And remember, you can't use a division sign. You have to use fraction bars in algebra. Next one. 3 times a number, so I wrote my 3 times x, added 2, so I wrote my plus. Then it says sum, so I went parentheses with an addition sign in between. And remember, just a couple words at a time. 3 times a number gives you that. Added 2 gives you this. Sum of a number and 6, parentheses, x plus 6. And I just added in the 1 and the things to satisfy this part. So if this was an Alex question, you wouldn't have the 1, you would just have 3x plus parentheses x plus 6. But because this one also says simplify, I added in the 1 and then you distribute so that you can simplify. But on Alex, you would have just stopped right there without those little arrows, without the 1, and just written 3x plus parentheses x plus 6. So added 2 plus sum means you have a quantity in parentheses with an addition sign. And then when we go to simplify, 1x plus 6, so we have 3x plus 1x plus 6 3x plus 1x is 4x plus 6 should be your final answer for that. But like I said, on ALEKS, you would just write this because it just asks you to translate. So 3x plus parentheses x plus 6. Okay, for the next one, this was the one I had you highlight in your notes from lesson 1. This is the one I told you a lot of students miss. So those 4 words mean 7 parentheses with a minus in front, because it's 7 times the whole difference, which is a quantity. So 7 parentheses with a minus inside. Then you find your and. Whatever's in front of the and goes first. X, whatever's after the and goes after the subtraction sign, 4. And again, that would be your answer in ALEKS if it asks you to translate, but this one also says to simplify, so then you'd write 7x minus 28. Okay, part E. 4 subtracted from, there's the from again. So 5 times a number must go first. 5 times a number, 5x, and 4 is subtracted from that. So minus 4. And then the next one's just the opposite. 5 times a number subtracted from 4. So 4's first, minus 5x. And then it asks, are these two the same? And that is absolutely not. In subtraction, order matters. And you can do just a simple little example to show that. Just take off the x's and say, is 5 minus 4 the same thing as 4 minus 5? No way. So those are not equivalent because subtraction order matters. That means subtraction is not commutative. Okay, so I hope you're getting better and better at those. Like I said, we have translations on every single test and quiz this semester. So I'm just going to keep reviewing them so you guys get really good at them. Okay, the second part of lesson 2 is solving equations, and I had just started it when I realized that the camera was not on. So I have a couple things written out here that I started, and then I saw the record button was not on. So silly me, I won't make that mistake again, I hope. So now we're actually going to start the solving process. Most teachers recommend or even ask for it on the test that you check the equations after solving. So I'm going to show you some of the little tidbits at the beginning, and then we'll start the actual solving. So this is a linear equation in one variable. So the variable's x, and then a, b, and c would have numbers in it. An equation, remember, must have an equal sign. And what we're going to be asked is to solve the equation. So we have to understand what a solution is. A solution, also known as a root later on in your upper level classes, is a value of the variable that makes the equation true. When you plug it in, you should get a true statement. And that's how we check. We put the number in we found. If it makes a true statement, then we go, yes, I got this one right. If it makes a false statement, that means you made an error somewhere, and you go back and check your work. So first, I just want to talk about vocabulary. An expression does not have an equal sign. This is called an algebraic expression. An equation has an equal sign. You will never be asked to solve an expression. We only solve equations. You might be asked to evaluate an expression. Evaluate 3x plus 8 at x equals 2. And you plug the 2 in and get the answer. So expressions we evaluate, equations we solve. So when I solve this equation, and you'll know how to do this by the end of the lesson, you'll have a value for the variable that makes the equation true. So it means you're trying to find the value of the variable. That's what solving an equation is. That makes this a true statement. When you plug it in, you'll get 4 on both sides. So first, before we start the actual solving, we're going to learn how to check. So, is 3 a solution? So that means you plug 3 in as the value of the variable and you see if you get a true statement. 3 times 3 minus 5, is that equal to 1? 9 minus 5, is that equal to 1? 4 does not equal 1, so 3 would not be considered a solution because it does not make a true statement. This is a false statement. So it has to be true. 4 equals 4, 1 equals 1 in order for it to be a solution. And that's why I love this chapter, because almost every problem on your test can be checked. All you have to do is take the answer you got, plug it in, and make sure it's a true statement. So now let's check B. Is 2 a solution? So this time we're going to put 2 in. And we want to know, is 3 times 2 minus 5, is that going to be equal to 1? 6 minus 5, is that equal to 1? Yep, it sure is. Ding, 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 ding. So then what we will learn to do is, once you've verified that it's a valid solution, a true statement, then you take the solution and put it in solution sets to show that it's a valid solution. So this one would be a yes. And what I see a lot of students do who are just learning this is they'll put the 1 in solution set. 1 is not the solution, 2 is. This just has to be a true statement. But the answer is always what you plugged in. So 2 is what I plugged in, so that means 2 is a solution, so I put it in solution sets. And because it's true, I write yes, it is a solution. So that's how we're going to do our checks on this. And we're going to start with nice simple equations, and by the end of the lesson we're going to be into multiple step equations. But we're going to start nice and simple in case it's been a while since you've seen it, or maybe never seen it. So we're going to start from the bottom. So the addition property of equality states that you can add any number to one side of an equation as long as you do it to the other side. So I like to say whatever I do to one side, I must do the same thing to the other side. So if I add 5 to one side, I must add 5 to the other side. And the sides are separated by the equal sign. So there's a left side and there's a right side. That's what they mean by sides. And I like to think of it as a scale. I got to keep it balanced. An equation means they're exactly the same. Equal means same. So if I do something to one side, I have to do the same thing to the other side to keep them the same. So with solving equations, we do what's called undo the equation in order to get the variable alone. Undo means do the opposite. So when I see this first one, I go, oh, the opposite of -4 is add 4. Because my goal is to get the x all by itself on the left-hand side. So to do that, I have to do the opposite to move everything to the other side. So opposite is subtract 4, add 4. But if I add 4 to the left side of the equal sign, I must add 4 to the right side of the equal sign. And this is why we do the opposite. 4 minus 4 is 0. That number is now gone, and my x is alone. That's what solve means. Get your variable alone. And you do that by doing the opposite, or undoing the operations that are on the same side with x. And so now on the left we just have x, and on the right we have 9 plus 4, 13. So before we put it in solution sets, we must check it. So the steps for checking are, first, write the original problem. Second, plug your value in that you think is the correct answer, and then just simplify like we did above and see if the two sides match. 9, should put a question right there, 9 equals 9, true statement. So remember, this is not your answer. You go back to this and go, yep, 13 works. There's my solution. Nice, right? So I love it that they started with nice, simple ones. So go ahead and do B, and then turn the video back on and you can check your work. Okay. Okay, to do B, it's very similar to the last one. My goal is to get X alone. So I add 2, that's the opposite of subtract 2, to both sides. So I get X equals 5. And then before I put that in solution sets, I must check it. So I write my original problem here. Then I plug in my value that I think is the solution. 5 minus 2 equals 3. Is that true? Yes, it is. Ding, 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 ding. That means I can go over here and in ALEKS, plug in 5 as my solution. This lets the reader know that it's been checked and it's a valid solution. And if it's a false statement, you go back and rework the problem. You don't just say, oh, no solution, or oh, it must not just check. It will always check. So if this is not true, that tells you to go back and rework the problem. If you can't find an error in the problem, then go back and rework the check. Maybe you made an error in the check, but they will always check. Okay, so I hope everybody has their calculators, and remember, you can't use phones on the tests and quizzes, and you can't use graphing calculators. So make sure you have a scientific calculator, because when you go to take a test, I have you hold it up for the camera so that I can see what calculator you're using. So you have to have a scientific, and this is the easiest one to learn on. And it's also, if you have a scientific calculator and you're already good at it, that's fine. Don't go out and buy a new one. But if you don't have one, get this one. It's the least expensive and the easiest to use. This is my baby. I love this calculator. For $14, it's amazing. So make sure you get one soon, because you're going to need one for your quizzes and tests. Okay, so this next one we have plus. Well, I'm trying to get X alone, so I need to do the opposite to get that 1.3 over here. So the opposite of add is subtract. So I'm going to subtract 1.3, subtract 1.3. So always do the opposite. Why? Because 1.3 minus 1.3 is 0. Mission accomplished. That's my mission. Get the variable alone. So now I have it alone. And you could do this by hand or calculator. I'll show you both ways. But checking definitely is easy with the much easier with the calculator. When the signs are the same, we add and keep the sign. So when you add, you need the same number of decimal places. So add and keep the sign. So I know the sign's going to be negative. I'll keep that there. 7 plus 0 is 7. 0 plus 3 is 3. Decimal straight down. 8 plus 1 is 9. So negative, that looks kind of creepy looking, doesn't it? All disjointed. Negative 9.37. To do it on your calculator, you have to remember that this is a negative, because this is what the problem would look like if you wrote it out horizontally, because students really have a hard time distinguishing between the negative and subtraction when they're first using the calculator. So remember, this is a negative. Negatives are numbers that are out in front. Subtraction are numbers in between two numbers. So this is a negative, this is subtraction. So when I go to type this in, I'm going to type negative and then 8.07. Whoops. Then I'm going to use the subtraction key, 1.3. And I can see I did the work correctly. So when you're doing your homework, anytime you can do it by hand, do it by hand. But when you're on a test, do it by hand then back it up with the calculator, because you want to make sure you didn't make a sign error or anything like that. So on tests, you definitely want to double check. Okay, so before we put that in solution sets, we have to check our work, and this is where I said the calculator is very handy. So we're going to put negative 9.37 in for x. So is negative 9.37 plus 1.3, is that going to give us negative 8.07? And this is where I said it's really nice and so much quicker to have the calculator. So we do the left-hand side, negative 9.37 plus, and remember that first negative came from down here, not here, plus 1.3. When I hit enter, I cross my fingers. I want it to be negative 8.07, and it is. Yay! So negative 8.07 equals negative 8.07. True statement. Therefore, I can go over here and write negative 9.37 in solution sets. So it doesn't matter how ugly the problem is, because you have your calculator. It does fractions, it does decimals, it does whole numbers, it does integers. So nice little fun fact. Okay, so this next one, when we have a problem like this, where the x is on the right, step number one, flip the equation over. We always want our x on the left. And the reason I say that is because when we solve inequalities in a week, I think we do it in another week, we start solving inequalities. If you don't have the x on the left, you'll get the answer wrong when there's a greater than or less than sign. So I like to start that now, right when we're learning equations, so you just have that as a habit and you don't have to change anything when you go to inequalities. Because my MO is I want to do every problem the same. Then I don't have to go, is this the one where I don't even have to say that. Do every problem the same, and then you don't ever have to ask your question, oh, is this the one that I do something different on? So if your x isn't on the left, you just immediately flip your equation. And then you make it look just like any other equation. So when you flip it, you don't change any signs. You're merely just flipping it over because they're equivalent. So it doesn't matter what side they're on. They're going to balance no matter what. But you keep them exactly the same. And then you start your process. I need to get x alone. So I do the opposite, minus 1/5, minus 1/5. And remember what I said, it does help sometimes to write it out horizontally. It's negative 2/3, so that's a negative sign, but it's subtract 1/5. So I tell students, if you're one that gets the negative and subtraction sign mixed up, write it out horizontally, keeping it in the same order. Then you can easily see that's a negative, that's a subtraction. And we learned in the last video how to do fractions. This is the fraction bar key. So we do negative down here, and then we do 2 fraction bar 3. So that's what negative 2/3 looks like. This is subtraction, and then we do 1 fraction bar 5. See why I like this calculator? It's so easy. Think of the work you would have to do. You'd have to multiply this by 5/5, this by 3/3, subtract the 2 new fractions, and then simplify. The calculator does it all in one button push. Ding, ding, ding. It's nice. It's super nice. So that means my apparent answer is negative 13/15. Then, of course, I have to go back and check it. So write the original problem. Now, when you do check it, you have to check into the original. You can't check into the flipped version. And that's one thing I notice a lot of my 1, 2, 6 students don't know, and they miss on the test. All checks must be in the original. There can't be anything done to this, like they'll square both sides at the beginning. No, It has to be the original exact same equation for the check. So then I'm going to plug negative 13/15 in for this, and you can see where your calculator is going to be so much help in doing this, so you don't have to keep finding common denominators and do all that work. Not that anything's wrong with that, but you might not be able to get your tests done if you're trying to do everything by hand. So save your by hand stuff on your homework, because you want to keep up, because in the 1-5 class, which is after the 1-2 class, they have tests that have no calculators. So, or some teachers will give the first part of the test, say everybody put the calculators away. Then when they bring that test up, then they'll say, okay, here's your calculator test. Pull out your calculators. So that's how I do it when I'm in 1-5. I do half calculator, half, or maybe 2/3 no calculator, 1/3 calculator. So you have to be able to do these things by hand for that class. So don't get rusty and do everything on the calculator. But for tests, definitely check everything with the calculator. So I want to know, is negative 2/3 the same thing as negative 13/15 plus 1/5? So I don't have to do anything to the left side. I just need to do the right side. So that's a negative sign. So go down to the bottom of the calculator. Negative 13 fraction bar. Whoa, whoa. This is why I love this calculator. Watch, I made an error. So I can go backwards and hit delete on top of that and then pick up where I left off. Is that so cool? So DEL is delete and INS is insert. So if you forgot a letter, you can do the same thing and do second insert and put a number in. So negative 13/15 plus 1 fraction bar 5. Cross my fingers. I need it to be negative 2/3. Yes! And it is. So negative 2/3 equals, on this side we got negative 2/3 on the calculator, which tells us negative 13/15 is our solution. See why I like solving equations so much? I'm kind of one of those black and white. It's either right or wrong. And I can tell instantly whether my answer is right or wrong by doing my check. So even when they don't ask for it, if you have time at the end of the test, go back and check problems. You would be surprised. My best students every semester are the ones that at the end of the test, when they have time, on a different sheet of paper, which they do submit as well, they start reworking problems without looking at them the first time and make sure they get the same answers. Or they go back and do checks because they weren't sure they were going to have time, so they go back and check them. Great way to do awesome on a test is rework your problems or go back and do checks after you finish the test and want to make sure. So don't submit your test. Just go back, because Alex lets you click on prior problems and you can rework them and verify that you're sorry. Verify that your answer is correct. Okay. So moving on. So that's called the addition property of equality. Sometimes we have a little bit of work to do at the beginning of the problem. So we always have to combine any like terms, and like terms can only be on the same side, by the way. So like I couldn't combine this with these over here. So when it says combine like terms, that means on each side. So combine the like terms on this side, then combine the like terms on that side, and that's step 1. Remove any parentheses and combine like terms first. That's why we worked on that at the beginning of this lesson. Then I start solving, because I've seen students start solving at this step and they get so confused at the end because there's so many steps they don't know what to do. That's why we simplify first. Remove parentheses, combine like terms. So over here, I have some like terms here. I have some like terms here, and another like term with those two in front there. And then I have some like terms here. So you can only combine terms that are on the same side. So this is 9 plus 4, 13K. But 13k minus 12k is 1k, which we all know is really just k, right? So 13k minus 12k is 1k. 6 minus 2 is positive 4. Equals 2 plus 8, 10. So now we just have a super simple problem, and I know that one's probably bugging you. Just get rid of it. So 1k, k, same thing. So that's what this problem bubbles down to. So instead of doing 53,000 steps and moving stuff from side to side, we first simplify, then it's a one-step problem. And I've seriously had students do like 6, 8, 10 steps on this problem because they forgot to simplify first. So we always simplify on each side. Then we do the opposite to get the variable alone. So the opposite of add 4, because this is what we want to get alone, is subtract 4. That cancels, so we get k equals 6. Now when we go to check this one, we do have to go into the original. So that big, messy, ugly first problem is what we have to check into. So I'm just going to rewrite it over here so I have it. I don't have to keep looking over. 9k plus 4k plus 6 minus 2. And I mean it has to be identical to the original. So don't do any work until you get your value plugged in. So now everywhere I see a 6, oh, do you just see what I did? Dang, I forgot the minus 12k. So 9k plus 4k plus 6 minus 2 minus 12k equals 2 plus 8. So all of the k's are now going to be replaced with 6. And that's one thing I see students do incorrectly on checks. They'll replace some of them, but not all of them. No, 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 no. Every k in the entire problem now needs to become 6. And like I said, if you do a check in this, every teacher in the nation will count it wrong. Checks must be in the original. And that's why we have a calculator. We don't care if it's a long, ugly problem. We have a calculator. So 9 times 6 plus 4 times 6 plus 6 minus 2 minus 12 times 6 equals 2 plus 8, not times 8. I'm losing my mind again already. Okay, so now you have to follow order of operations. Please excuse my dear Aunt Sally, no parentheses, no exponents. So next is do all the multiplication, So P's done, E's done. We're on M, which says do all the multiplication. So this is going to turn into 54 plus 24 plus 6 minus 2 minus 12 times 6, 72. And we want to know, is that going to give us 10? So this is when we use the calculator. So we're just adding a big string of numbers. So 54 plus 24 plus 6, subtract 2, subtract 72. Cross your fingers. Yes! 10 it is. So this side gives me 10. This side gives me 10. That means my solution is correct. So then I come over here and put my 6 in solution sets to enter it in Alex. So even when they get messy, never fear. We have the calculator and we can do all that work with the calculator. Nice, huh? Okay, so if there are variables on both sides of the equal sign, step 1 is combine like terms on both sides. Always step number 1. And remove parentheses on both sides. So we always have to simplify first. And we remove parentheses first, then we combine like terms. Because we know from PEMDAS, parentheses are always first. So remove any parentheses by doing distributive, combine like terms on each side. Then step 2 is we move all variables move to the left. And remember, variables are letters. So all variables move to the left. All constants move to the right. And remember, anytime you're moving, crossing an equal sign, you must do the opposite anytime you're crossing the equal sign. So all variables move to the left, all constants move to the right. Okay, so you're ready to practice? So these are going to have variables on both sides. Some of them, these two do not. So these are just kind of peculiar ones where you have to remember to add the -1 in here, add the -1 here, but these go with this above. So whenever I see that I'm going to move a variable over to the left and it leaves me with nothing, I move the constant first. Remember, a constant is anything without an x on it. And there's no simplifying here, no like terms over here, no like terms over here. So I'm already on step 2. And order on this doesn't matter. Usually I do this first. The only time I don't is in this scenario, and I know this one is on the test. So order doesn't matter, but 95% of the time I move the variables to the left first. But this is one exception, because if I move that over, there would be nothing here. And a lot of students forget to put the 0 in and they just lose one side of the equation. So when that's going to happen, just move your constant first by doing the opposite. And so now I have 4x equals 5x minus 8. So this step's done. All my constants, anything without letters, are now on the right. So now I go up to this. I need all variables to the left. And this is where students make a lot of mistakes. They go 4x plus 5x, 9x. Never. Every time you cross an equal sign, you must do the opposite. You can never add things that are on different sides of the equal sign. So I need this over there. Right now, there's no sign in front. That means plus. So I do minus 5x minus 5x. And that gives me -1x equals 5 minus 5 cancels -8. And anytime we have a negative in front of an x, that means -1 times x. So remember what I said, we always do the opposite. The opposite of times -1, divide by -1. And so -1 divided by -1 obviously cancels. So we get x equals 2 negatives, always a positive. So that would be +8. And just for time reasons, we're not going to check these. Every once in a while, I'll see a good one and I'll check it, but we're not going to check all these since we did so many at the beginning. But on your test, I would definitely check them if you have time at the end. Okay. Is everybody okay with that one? Yeah. So -1 times, the opposite of times is divide. 2 negatives make a positive. So +1x, which is just x, equals 2 negatives make a positive, +8. So every time I see 2 negatives, the first thing I do is make them positive. And you can even do a quick head check if you want. 32 plus 8, because 8 times 4 is 32, 40. 5 times 8, 40. So if you're kind of on a rush budget, you can even do easy ones like this in your head. I see that this side was 40 and this side was 40. But hopefully you'll have time at the end and you can come back and check these. Okay, so this one, another busy one like above. So we first have to combine like terms. We don't have any parentheses to remove so far, but we do have some like terms to combine. And remember, you can only combine them when they're on the same side of the equal sign. So I could never combine these three. Combine them on the left, combine them on the right. If there's an x without a number in front, remember and put the 1 in. So this would be positive 11x and minus 1x. And then last we would add the constants. So that's going to give me 12x plus 6 equals, and I like my x first, so I'm going to do that first. 11x minus 1x is 10x. And 8 minus 10 is negative 2, because the signs are different, so we subtract and keep the sign of the larger. So now I have what's called a normal problem. So I have x's and constants on both sides. So now I do this. And like I said, I almost always, except for this scenario, move my variables first. So I need this on the left. So again, it has a plus sign in front, so to move it over, I would subtract 10x and put it underneath its like term on the other side. So 10 minus 10, 0. 12 minus 10, now I have 2x plus 6 equals negative 2. So this step's done. All variables have been moved to the left. Now I need any constants, that means numbers without variables, move to the right. So this needs to move over here, so do the opposite, subtract 6. And that leaves me, that cancels, 2x equals, when the signs are the same, we add and keep the sign, so that'll be negative 8. And then my last step, do the opposite to get x alone. So the opposite of times 2, divide by 2. And I get x equals negative 4. And I'm going to go ahead and put these in solution sets just because I know that's how you're going to have to enter them in ALEKS. Just so you get used to doing that. So that was a pretty heavy-duty one, right? Okay, I'm going to let you guys try the next two. This one is sort of like this one. Got to do some work at the beginning. This one is like this one when you get to this step. So the best way to learn is practicing. So shut off your video, do those two. And I'm going to give you 2 hints, okay, before you do that. First one is, don't forget, like we did on the last lesson, if there's a negative in front of parentheses, you're distributing -1 to everything inside. So many students miss this problem because they make it -5x and they keep it +1. Put the arrows in so you don't forget to distribute. And then this one, it might be helpful also to put that -1 in. Okay, go ahead and shut off your video and then come back and check with me when you're done. Okay, on this first one, we have to start with the distributing. We already have our -1 in place there. So 3 times 2x, because remember, we have to remove parentheses first before we can start the problem. So 6x minus 15, 3 times 2x, 3 times -5, -5x, and -1 equals -3. So 6x minus 15, negative 5x, negative 1. And then step 2, combine like terms. So we have some like terms over here, 6x and negative 5x, and notice I always circle the signs in front as well. And then when I'm doing this, I always include the sign, negative 5, negative 1, so you don't forget. So 6x minus 5x is 1x, which is the same thing as x. Negative 15 and negative 1 is negative 16, equals negative 3. And then we want to get our x alone. So we're finally ready to start moving. So to get this x alone, we do the opposite, plus 16, because now we're crossing the equal sign. Here we didn't do any crossing. Everything stayed on the left, so we didn't do any opposites. But now I'm bringing this across the equal sign. Now is when I do the opposite, because some students get confused on that. They're like, why didn't you write plus 5x plus 5x? Because I'm not crossing an equal sign. I'm just combining like terms. We only do the opposite when we're bringing a number over to the other side of the equal. That's one of the things I notice a lot with beginning students, is they do the opposite when they're combining like terms. But if you're not moving it to the right side, don't do the opposite. So negative 16 plus 16 cancels, and 16 minus 3 is 13. So that gives me a solution of 13. Hope you guys did good on that one. That's a good one for a test. I like that one. Very nice problem. Not too hard, not too easy, just right in the middle. Okay, this one is a little confusing for students because they want to add 5 to both sides because they're looking at this sign. This is x's sign. It's not 5's sign. So my x's are already on the left, but I need my constants on the right. So you have to remember, a number with no sign in front means there's an invisible plus there. So you would not add 5 to both sides. You would subtract 5, because that negative is not 5's sign. It's x's sign. And maybe it would help, and I'm a big colored pen fan on tests, to do things like this to remind you that's x. You need to get it alone, so do the opposite of plus 5 minus 5. So then I get negative 1x equals 15. 5 minus 5 cancels. This is a times sign, so the opposite of times negative 1 is divide by negative 1. And double negative positive. So 1 divided by 1 is just 1x, or x. A positive divided by a negative is negative 15. So the rule is an odd number of negatives in division, negative answer. I just had 1. An even number of negatives, that means 2 negatives, that gives me a positive answer. Like here. Here I had 2 negatives, that's an even number, that's why my answer was positive. Here I had 1 negative, that's an odd number, that's why my answer is negative. But if you struggle with signs, just follow it up with your calculator to make sure you didn't make any sign errors. You can certainly type in negative 8 divided by negative 1 on your calculator, or positive 15 divided by negative 1. So don't guess on tests. That's why you have a calculator. Okay, I think I'm going to save this for our next lesson. So we'll end lesson 2 right here. Okay, so I'll see you on lesson 3. Don't forget to do your homework. Remember what your goal is each day, Monday through Thursday. It's a 4-day class because it's 4 credits, so I just break it into 4 days. So an hour on Monday doing notes, an hour on Monday, 1 to 2 hours doing ALEKS. An hour on Tuesday doing notes, 1 to 2 hours in ALEKS doing the topics from those notes. Do that 4 days a week, then you'll really have homework on the weekends. Okay, see you next week.